for one apple is 9, then if I'm trying to get 2 apples, then that would be 5 times 9. So my new mean is 45. For a standard deviation, I can really only compare variances. That's one thing. I'm not sure if we completely went over, but you can only compare variances. So what I can do here is I can say, well, the variance is 0.75 squared because the standard deviation is 0.75. And there's 5 of those. And if you multiply those out, you get 2.8125. Remember to go to 4 decimal places on this test always. And then you take a square root and to get to the standard deviation, which is 1.677 ounces. So remember, if you're combining different things, you can always combine the variances, but you can't just combine the standard deviations because they will affect each other. What's the probability that the total weight of the... Oh, and make sure you always label your answers. They will sometimes take points off for that. What's the probability that the total weight of 5 randomly selected apples will be less than 42 ounces? That's the problem I was waiting for. Alright, so we know that the average is 45 and that it's less than 42. So here's 42 over here, less than's over here. Okay, so this is x minus mu over sigma, except for I have to use the sigma that I just got and the mean that I just got. So I need to make sure that I use those. Okay, so this is 42 minus, the mean is 45, divided by sigma, which is 1.677. All right, and that gives me a z-score of negative 1.79. That's a z-score. And then if I look that up in my chart, I find out that that area is 0.368. Okay, and yeah, because they're talking about population means here. They're talking about the weights of all red delicious apples are approximately normally with a mean of that and a standard deviation of that. They're not talking about like they went out and they got a sample of some stuff. This is a mean, a population mean. So, okie doke. So now, an interesting question says, the combined weight of the packing material and the box in which the apples will be shipped is always 10 ounces. Okay, so let W represent the weight of a completed packaged gift box, which consists of the packing material, box, and 5 randomly selected apples. What's the mean and the standard deviation of W? So W is essentially, so W equals 10 ounces, no matter what, because that's the shipping, plus those, we've got like, what, those 5 apples. So for the mean, it's just as simple as saying 10 plus 5 times 9. So it used to be 45, right, for 5 apples, and now it is another 10, so my new mu is 55. As far as standard deviation, and this is important, standard deviation doesn't change if you add a constant. By constant, I just mean a regular number, nothing with a variable. So that would be, so for example, I know this is not, I'm not going to make this a confidence interval, but I am going to kind of show you here. So the average for just the apples by themselves would have been 45. And then if you add or subtract to that 1.677, you get to 46.677. And this one over here would be 43.323. But if I add that box in, it doesn't really change because the box, you see, is always 10, no matter what. So the amount that the whole thing is deviating by is still only that 1.677 on average. So this would now be 56.677, and this one would be, what, 53.323. These parts are not needed in your explanation. They're just something I wanted to talk to you about. You could just literally write standard deviation doesn't change. If you add a constant and write down that sigma is still 1.677. Just make sure you have an explanation with it. Don't just write the answer. Make sure that you, if you're thinking, yeah, but they know that standard deviation doesn't change if you add a constant, they're testing you. That's the point of this, to see if you know. So make sure that you explain all of your answers. All right, guys, I'll be back tomorrow with another couple problems to try out and some video to show you how I would do it as well. If you need anything from me, if you need questions answered or you need copies of notes, please reach out and I will get back to you. I miss you. Bye.